Hello and welcome to the Friday, February 21st, 2025 edition of the SANS and Storm Center's Stormcast. My name is Johannes Ulrich and I'm recording from Jacksonville, Florida. Well, in diaries today, we had one by Guy showing us how to use the Elasticsearch piped query language in order to do a little bit more interesting queries against Honeypot data using some of the recent expansions to that query language. Nice little use of Honeypot data, really just to gain some experience with these query features in a more sane environment before sort of rolling something like this into production and actually deploying it to your Elasticsearch instance and build dashboards around it. Well, and if you're using MongoDB, be aware there is an interesting injection vulnerability. Not calling it here SQL injection, even though some of the write-ups call it that way, but Mongo technically is NoSQL, but the vulnerability is very similar, and it's actually not in Mongo itself. Remember, we had recently that Postgres vulnerability where an associated database had the actual injection problem. Similar here, there is a library called Mongoose. Mongoose is an object data modeling library. It simplifies queries by basically just allowing you to store, retrieve JavaScript objects from MongoDB. Mongoose does then the rewriting into the actual query language. Well, that's going wrong here. There were actually earlier patches late last year that were not sufficient. So definitely make sure that if you're using MongoDB and if you're using Mongoose as sort of that intermediate layer to query MongoDB, that you have everything up to date. Same is true for many of these object relational mapping, object data mapping libraries. They abstract a lot of the underlying query languages, but as a result, of course, you're relying on these libraries to do any escaping prepared statements and such correctly, which sometimes fails, like in this case or in the Postgres case. And then we got a number of vulnerabilities. I think it's a total of 6 in U-Boot. U-Boot is a bootloader that you often see in a embedded system. I remember seeing it, for example, in NetOptics, tabs. I sort of ran into that, I think, last year. But this is a type of system where you would find U-Boot. And like many bootloaders, one of the goals of the bootloader is to ensure the integrity of all the software being loaded, basically operating system. Well, that's exactly the nature of these vulnerabilities that the attacker could essentially inject malicious software that would then not be recognized, or the modification would not be recognized, and that could lead to essentially bootloader malware that's very difficult to detect and to eradicate. Updates are available from the U-Boot project. It's an open source project, but of course you typically don't install sort of U-Boot from scratch. So wait for your particular devices or so to possibly come up with the respective update. And if you're using the very popular Unifi cameras as part of the Unifi Protect system, be aware there is a new camera firmware that's available. So this is not a new version of Unifi Protect. It's just the camera firmware that needs to be updated here. It fixes 2 critical vulnerabilities and then a couple of, high-medium vulnerabilities that essentially, as far as the critical vulnerabilities go, are authentication bypass issues that would allow remote control, at least of the cameras. The updates should be applied automatically in my experience and applied relatively quickly, but you may want to double check that the firmware that you're running is at least 4.74.106. Older versions are vulnerable. Well, and today it's Friday again, so I have with me another SANS.edu student. Austin, could you introduce yourself, please?
Sure. I'm Austin Clark. I'm the Enterprise Security Architect at the Department of Transportation and a SANS alumni.
So great. And your research paper was about network devices. Can you sort of briefly explain what the topic was all about?
Sure. It was basically how to treat network devices like endpoints and detect adversary actions when they target them specifically, how to protect those network devices, and detect MITRE attack techniques.
Yeah, and I think there's hardly a day, definitely not a week in this podcast where I'm not talking about vulnerabilities in various network devices. So it has been a big issue. What are some of the logs or such that you're considering here from these network devices?
Sure. The key logs that we were able to use for detections were syslog, which was not as helpful as the AAA logs.
Given that you're collecting this data over the network, and of course, it's a little bit different data than you're getting from a normal endpoint at a normal server or something like that. Uh, do you see like different usage patterns or such that in these network devices compared to your classic endpoint devices when it comes to these logs?
Yeah, so it's always your network administrators that are logging in. So the logs, when they're coming into something like a Splunk seam or Elastic, they're a lot lower. There's not as many of the logs, and that means your detections can have a much higher fidelity. You can also filter out a little bit easier the known good, like there's a specific scanner account or an admin account that they're using. Um, from a specific network appliance that like uploads configs or backs up configs, you're really able to filter out the noise fairly easily and get to clear detections.
Once you expose these network devices to the internet, does that change where you have more background noise from just random attacks?
Oh, absolutely. You almost never want these kinds of network devices, switches, routers, wireless LAN controllers exposed to the internet. We see specialized network appliances that are getting attacked constantly. We see CVEs for F5s, um, Cisco VPN concentrators, Palo, all the time. Um, so you really don't want your internal network devices exposed to the internet ever. But yet we still see it in Shodan all the time.
Yeah, it still happens. Because I think one of the advantages you mentioned is like that lower log volume. And theoretically, you could get that for your normal endpoints too, if you could restrict what your users are doing kind of to only very specific things, which of course doesn't work like, for your standard, let's say, workstation or something like this. But what you're saying is basically that for these internal network devices, you can limit where the connections come from, and you can limit who's connecting to it, maybe even when they're connecting to it. So this makes it much easier to then create some kind of rules and alerting around it.
Yeah, absolutely. AAA is a super powerful tool. What I've seen in a lot of networks is they just give the network admins privilege 15 and let them go with that. But you really could lock it down and block certain commands like clear logging and clear archive, erasing and exporting PKI. These exporting PKI is an esoteric thing that almost no network admin uses, but yet they have the capability when they aren't limited, right? You could block those commands and write detections on them so that the SOC analysts can immediately get alerted when those kinds of actions occur.
Yeah, I think I remember in your paper you wrote about installing certificate authorities, I believe, and updating them in the device. That would be something that really should almost never happen, or
Yeah, it should almost never happen. It, there's no reason to export the PKI so you can reuse it, but it is a command on certain Cisco devices.
yeah. So what kind of attacks do you see against these? Who is attacking those devices?
Yeah, so the paper definitely starts out with the why, and the why is really important. So we see multiple Russian threat actors consistently attacking network devices: Grizzly Steppe, Dragonfly, Berserk Bear, and even some Middle East non-nation state hacktivists like Gecko Jackal. So if those are in your threat profile, you're going to want to prioritize looking at your network devices more in depth, looking at the logs, doing these detections, implementing these protections.
You mentioned a couple seams, Splunk, Elasticsearch. They all work with these kind of logs.
Yes, so almost every SIEM can ingest syslog from Cisco devices or other network devices, as well as AAA logs. But the beauty of the rules that I wrote they're in the Sigma rule format. So you can import them to any seam that Sigma supports an export for. So QRadar, all the big popular ones. And those detections can be implemented fairly easily for the SOC analyst to start tuning. And they're definitely going to need tuning in any enterprise.
I don't remember the rules that you specifically wrote, but typically the Sigma rules are fairly readable, or so even if you don't have an automatic import, you can probably rewrite them in whatever rule language your seam supports.
Absolutely. It's a simple human readable YAML. It's not a JSON.
Well, okay. I like JSON better than YAML.
I do like JSON, but at least the Sigma rules are easy to read.
Yeah. Okay. Excellent. So anything you learned since you wrote the paper? It was a while ago that you wrote the paper. So anything that you learned applying some of this?
Yeah. So the paper was basically a big purple team event. Generate the logs, use Kali Linux to exploit and attack the devices, see the logs that are generated, write the rules, and then I tested the rules in the enterprise environment. And so I've tested them in a few enterprise environments since then. And it's critical to tune the detections. That's number one. A few more people have updated Sigma rules. So now there are Juniper and Huawei as well. The Cisco ones were the first ones that actually were added to Sigma for network devices specifically. That's different than just the network-based detections with like Zeek or something. And then I worked very closely with MITRE to get the network enterprise matrix updated. There was originally only 27 techniques, and then when I contributed the results of this paper, it jumped to 40 techniques in April of 2022. And since then, it's already up to 90. So people are really looking at network devices. They're seeing how many different detections they can implement. And I think this space is still something that every SOC needs to have.
Yeah. So thanks. Great to have you here. So thanks for contributing what you learned. And yeah, that's it for today. So thanks everyone for listening, and talk to you again on Monday. Bye.